Logarithms part 2. In this video we're going to talk about properties of logs. We're going to expand some logs and condense some logs. It's probably going to be a little bit longer than part 1. In part 1 we just introduced the basics of logarithms. If you haven't watched part 1 yet, please go back and do that. And then when we get to part 3 next, we'll solve equations, logarithmic equations and exponential equations. But first, let's do some properties. Alright, so we're first going to start with the multiplication property. So if I see an expression that says log base of something and then it has x times y or something times something, I can split those up into log base a of x and y, and I'm not going to multiply, I'm going to add. So multiplication in logarithmic world translates to addition. So this is called expanding a log right there. We can expand this one too. Here we have a division. So if multiplication goes to addition, division is going to go to subtraction. And here we have exponential property, the power property, where all I need to do is take this exponent and bring it down in front. So that n comes down in front, log base a of x. So they get multiplied together. Those three properties we're going to use for our expansions and our condensing problems here in a second. Let's start with number 1. Actually, let's do 1 through 4 as a group. So in this group, we're going to expand the logs. So here we have a base of 10. As I mentioned in part 1, if the log base is not written, we assume it to be 10. We don't have to write that base. All we need to do is say if they're multiplied here, they're added here. So 2x and y, and we're done. Same deal, there's a base of 10. I don't need to write that though. It's log of 8 minus log of 7. Division goes to subtraction, multiplication goes to addition. This one has another base of 10. I don't need to write that though. All I need to do is get this exponent down in front. So I write 5 log of u. This one is the square root of x, so I'm going to rewrite that first as x to the 1/2, as I know the square root of x is equal to x to the 1/2. And then I'll use my power property, 1/2 log of x. Simple as that. So just basic simplification. 5 through 7, or 5 through 8 rather, we're going to condense. So we're going to take these crazy looking logarithms and just kind of simplify them down into their easiest expression. So when I see log x over 3, I'm going to rewrite it as this. Now I'm sort of working backwards with my power property. If there's a number out in front, I'm going to move that up into the exponent. So I can probably quit there, but you also want to hopefully get into the habit of understanding that x to the 1/3 is equal to the cube root of x. So that's where I would leave it right there. Moving on, we have a subtraction. They have the same base, base 10, base 10. So this is going to be a base 10 logarithm, 2 over 11. Number 7 is an addition, same base. If they're added here, then they're multiplied here. 8 times 3 is 24. And if this can be simplified, you would simplify it, but it cannot, so I'll keep it there. Number 8 is, just like number 5 was, log a. I'm going to take that 2 and I'm going to move it up here. That's all I'm doing. Alright, so learning how to work sort of in both directions here, you know, going this way and going this way is important. And depending on the problem, you're going to have to, know how to do both. So let's continue. Number 9, a little bit more complex. So I have log base 6, and I have a multiplication here. So it's c plus log base 6 of this craziness. Alright, let's keep going. Anytime I see a cube root. I'm going to change that to a times b to the 1/3. And then that 1/3 gets brought down in front. So log base 6 of c plus 1/3 log base 6 of a times b. The a times b can get broken up itself as an addition. So it's going to be log base 6 of c plus 1/3 log base 6a plus log base 6 of b. But these need to go in parentheses because the 1/3 actually affects both of them. And if you wanted to, you can of course bring that 1/3 in. So 1/3 log base 6a plus 1/3 log base 6 of b. And that would probably be the final answer. I imagine either of these two are fine. Number 10. A couple different ways to do a lot of these problems, as was the case with all my exponent videos. You have options, but maybe I'll show you both options here. So if I go first option, I take this 5 and I move it down in front first. So I say 5 log base 3 rather, x over y to the 5th. Division actually it translates into subtraction, so 5, and then log base 3 of x minus log base 3 of y to the 5th. That 5 can come down in front of this, so 5 times the quantity of this minus 5 log base 3. And you would probably want to bring that 5 into both of them, so 5 log base 3 of x minus 25 log base 3, and that would be good. The other option would be to take the 5 and distribute it into both terms first. So let's see if this is any quicker. X to the 5th over y to the 25th. That translates more into, moving down here, this is division, so we're going to translate it into subtraction. The exponents come down in front, 5 log base 3 of x minus 25 log base, should have a 3 there, log base 3 of y. And you can see that this answer is the same as this answer. So pick your favorite method. Number 11. For this one, you can probably just turn this into a 9 first. 3 squared is 9, so let's do that. Log base 6, 9 over, what is 7 to the 4th power? Let's see. 7 to the 4th power. 2401. So I'll just translate that into subtraction. If that weren't so easy to do for some reason, you can do this method too. You can say log base 6, 3 squared minus log base 6 of 7 to the 4th, 2 log base 6 of 3 minus 4 log base 6 of 7. The exponents would come down in front in both cases. So these are synonymous. They don't look the same, but they are. Moving on. Number 12, I would probably take again we have two options, but maybe I'll just show you one. Take the 5 and bring it down in front first. So 5 log base 5, 3 times 11 squared. 11 squared is 121. Maybe I'll just keep it like 11 squared. I think that's what the problem intended. So let's split these up, 5, and then log base 5 of 3 plus log base 5 of 11 squared. So 5 times the big parenthesis log base 5 of 3 plus 2 log base 5 of 11. And if we bring that 5 into both now, 5 times 2 is 10, and I'm finished. Very quickly, the other method would be to take the 5 and distribute it in first as an exponent. So 3 to the 5th times 11 to the 10th. So it's log base 5, 3 to the 5th, plus log base 5, 11 to the 10th. And then the 5 comes down in front, and the 10 comes down in front. You've got the same thing. Let's condense this one into a single expression. When I do that, if I see a number in front, I immediately move it into the exponent of both. So log base 9 of u squared plus log base 9 of v to the 12th. They're added, so let's condense them into a single log that's multiplied, u squared times v to the 12th. And I'm done. Again, fractions, what I'm going to do is maybe change each one into 1/2 log base 4 of 2, 1/2 log base 4 of 3, 1/2 log base 4 of 5. That number goes up into the exponent, log base 4 2 to the 1/2 plus log base 4 3 to the 1/2 plus log base 4 5 to the 1/2. And they are all added, so watch this, they all have the same base, so I can multiply them all together. 2 to the 1/2, 3 to the 1/2, and 5 to the 1/2. That 1/2, of course, translates into the square root. So 2 times 3 times 5. And 2 times 3 times 5 is 30. So log root 30 would be your answer. Last one. The 4 goes up as an exponent. The 8 goes up as an exponent. They have the same base. They're added, so we can condense them and multiply them together. And that's all you can do for that one. So there you go. There's some problems about expanding and condensing log expressions using the properties. In part 3, we're going to look at how to solve equations, logarithmic and exponential equations. So thank you for watching.